So in this practice problem, we're going to find the derivative first and use that to write the equation of the tangent line. So let's do part A first. So to find the derivative of this function, I will need to do the product rule. You see why, right? We have a product of this red times this green. When two things are multiplying, we're going to have to use the product rule. So here's my big outline. I'm doing product rule, which says first times the derivative of the second plus second times the derivative of the first. My first is that red highlighted 2x plus 1. The derivative of that is just 2. My second function is what I highlighted in green, x squared minus 1 raised to the third power. Now, chain rule has to come in for me to take the derivative of this. So what's g prime? Well, the 3 comes down to the front. This 3 right there comes to the front. And keep everything the same inside the parenthesis. But exponent goes down by 1 to 2. But I'm multiplying this by the derivative of the inside part, which is 2x. If you multiply this 3 by 2x to simplify, you will get 6x times x squared minus 1 squared. So we found all 4 pieces of our product rule. So let me go ahead and put these together. The derivative of this function will be, all right, what did I put first? First times, and the first is just 2x plus 1. So write that down first, 2x plus 1. We multiply this by the derivative of the second piece, the g prime. And remember, g prime is what we found over here using the chain rule. So you write that down, but I'm going to put the 6x in a parenthesis too. 6x, x squared minus 1 squared. And then put the plus sign, plus. All right, let's go grab that g. G is this. That's g. X squared minus 1 cubed. And we multiply this by f prime, right? And what was f prime? Oh, look, it was just 2. So you know what I'm going to do? I'm going to squeeze in that 2 in front of that parenthesis. Okay? All right. Now let me see if we can factor this out a little. It's a little bit messy. Okay? Any common factor you notice? This right there. E. Hold on. There's x squared minus 1 squared. And there's x squared minus 3. X squared minus 1 to the third power. So that's my common factor I want to get out. Okay? So let me write that out. X squared minus 1 squared outside. And let's write down the leftover. The leftover from the first part is this 2x plus 1 times 6x. Before I write that down, how about I just distribute it and I'll write that here. Okay, that will give me 12x squared plus 6x when I distribute, right? What's left in the second part? Well, if I factor out x squared minus 1 to the second power, right? If I factor out 2 of it from 3 of it, I still have 1 left, right? So the second part will look like this, okay? Well, we'll still have that 2 in front of it, right? This 2 comes down, but you'll have the 2. But you'll have 1 of this parenthesis left, which we can definitely distribute now, right? All right, let's see. So keep this x squared minus 1 squared the same. But let's see if we can simplify this by distributing that 2 first. Okay, I'll bring this down. But when you get that out of the parenthesis, you'll get 2x squared minus 2. Oopsies, 2. And we may be lucky to have any like terms over here, and I think we do. So I'll bring this down the same. But I notice there is 12x squared and 2x squared. If you combine them, you get 14x squared. And let's bring this plus 6x, this one right there, and that minus 2. we can factor this out even more. We can factor out, because you see everything inside here is even number. Let me factor out the 2 to the front. Keep this the same. But if I divide everything inside here by 2, take half of everything, I'll get 7x squared plus 3x minus 1. I don't even want to know if this trinomial can be factored at this point, but this looks pretty clean to me, so I'll stop there, okay? So that's the derivative of y. Now, I'm going to try to find the derivative of, not the derivative, I'm sorry, the second part, equation of the tangent line, okay? If I want to find the equation of the tangent line, I need 3 things. I need x, I need y, and I need m. If I have these 3, I can find the equation of the tangent line. They gave us x is 0, but what's y? They never give us y. Well, we'll have to find it ourselves then. We can find y by plugging in the x value into this function, right? That's what y is. So I'll do the work down here. So here's my work to find y. Y equals 2 times 0 plus 1 times 0 squared minus 1 cubed. Well, that's going to be 1 times negative 1 cubed, right? That's 1 times negative 1, which is negative 1. So if you plug in 0 into the original function, you get to have the y value of negative 1. Now, how do we find the m value? Well, m comes from our derivative, okay? You got to plug in 0, the x value of 0, into the derivative function, okay? So that's going to give us 2 times 0 squared minus 1 squared times 7 times 0 squared plus 3 times 0 minus 1. All right, let me simplify this. This will be 2 times negative 1 squared. These all turn into 0, leaving me with just negative 1. This is 2 times positive 1 times negative 1. So the sign will be negative, the number will be 2. So slope of this tangent line is negative 2. All right, now we are ready to find the equation of the tangent line, okay? Using point slope form. Point slope form says do y minus y1 equals m times x minus x1. So plug in all the values we got. Y minus the y value of negative 1. If you subtract negative 1, that turns into adding 1. Put that m here. M value was negative 2. Inside the parenthesis, I have to do x minus x1 of 0. X minus 0. Let me simplify this. I'll get x plus 1 equals negative 2 times x. Well, if I subtract 1 from both sides, I get to write this in a slope-intercept form of y equals negative 2x minus 1. So that's how we can find the equation of the tangent line using the derivative function.